In this video, I'm going to show you how to do simple integrals. In another short lecture, I'll show you how to do more advanced integrals that are more similar to what you might encounter in an upper level physics homework problem. Okay. The first thing I'm doing here is I'm clearing all variables. Notice the kind of wildly complex syntax here you need to do if you want to clear all variables, which I'm doing, by the way, because I have a lot of different notebooks open right now. I'm making a lot of videos and I want to make sure I'm starting each notebook with a blank slate. Okay, but you need to use this exact syntax. You need to use the quotes. You have to capitalize global. You have to use this reverse prime and the asterisk here. I didn't invent the syntax. I just use it. But if I run this cell, it'll clear all the variables in this notebook, okay, or that have been defined in any notebook. Okay, so you lots of blue stuff below. Okay, next I'm going to define a new function to integrate. Okay, we talked about function syntax in another lecture. This is a delayed function. So when I run this, I'm actually not going to get anything out because it hasn't evaluated it yet. Okay, but notice A and B, those are undefined variables. That's okay. And in fact, it's common when you're using Mathematica and physics to want to integrate a function where you don't have numbers, right, for all of the variables yet. Okay, this particular function depends on x. And notice that it has another built-in function in it, sine. I know it's built in because it's capitalized, okay? If I use a lowercase sign, notice now it's blue, which means it's not a built-in function anymore. It's undefined, right? Mathematica actually doesn't know what to do with that particular function. So if I want to use a predefined function, I better spell it right, and it better show up black, or else Mathematica won't know what to do, okay? Okay, but now I want to integrate that function, and I'm going to do an indefinite integral first, okay? And again, note the notation here. I'm using capital I for a built-in function integrate. Okay, again, if I use the wrong function name, or if I forgot to capitalize it, it's going to turn blue. It's not going to be black. If I want some more help on the syntax, notice when I type or when I hover over integrate, I get two options here. The I will open a web page, the Mathematica help for integrate. These two downward carrots will give me some examples of how the syntax, which is really helpful, by the way. I suggest using this, okay? But basically, I want to integrate the function x, which depends on x here, so I do have to put that portion in here, and I want to integrate it with respect to the variable x, okay? So I can go ahead and run that, and if you want, you can double check, but this is the correct integral, okay, of the function x with respect to x. Okay, if I wanted to, I could store this in a new function, maybe that depends on a and b, like that, okay? And now if I wanted to, I could evaluate that new function for certain values of a and b. Okay. So let's go down here. That's how I do an indefinite integral, or now I'm going to do a definite integral. So I want to integrate the same expression, but now I want to do it between the limits of 0 and 1. Okay, so again, notice I didn't have to put x in. I could put any variable in here. It'll just replace x with whatever variable I use. But whatever variable I put in between the square brackets here, if that's what I want to integrate over, I need to define that here, okay? So now instead of just having x, I've got curly brackets, and it has to be curly brackets, the variable I want to integrate over, the lower limit, and the upper limit, okay? So if I run this, okay, now it's evaluated this integral at the limits, okay? If I want to get some numeric values out instead of having cosine of 1, I can force it to do that with the \\, capital N. All right, let's go. Oh, I guess I just did that here. Sorry. We'll run that again. Okay. I don't actually have to have defined limits. I can have undefined limits. So just to give you an example here, now I can evaluate the function from t to 2t. So again, this is something you might do in a physics class, and it will put in those limits as variables, okay? And again, if I wanted to, I could define a function g, right, that maybe depends on a, b, and t, And I can set that equal to what comes out of the integral here. Okay, and then if I wanted to, I could evaluate that function at those values. Okay, and even get one number out. Okay, so if I want to, I can also set limits to infinity. Okay, I want you to notice that infinity, as long as I spell it correctly and capitalize it, it's built in. Okay, so here I'm integrating e to the negative x squared from x going from negative infinity to infinity. Again, if I forget to capitalize it, notice it's blue. That's not good. Okay, and if maybe I don't remember the variable name, it's also blue. So this is a help. Okay, this helps you figure it out. And notice actually when I start typing, Mathematica is also helping me by giving me some suggestions. It's kind of trying to figure out what it is that I want there. Okay, but this looks good to me. Let's go ahead and evaluate it. Nice, we're getting a good, this is a common integral to do. Nice solid answer, square root of pi. Those were all single one-dimensional integrals, but you can do multi-dimensional integrals as well. Here's an example. Again, I'm defining a delayed function now that depends on theta, r, and phi. Or it actually doesn't depend on phi, but that's okay. It just depends on r and theta, but I can say it depends on three things. Okay. I'm calculating the volume of a sphere here. Okay. So I'm going to integrate that function that depends on three variables. So I got to put each of the three variables here, and I'm going to do a three-dimensional integral. Okay, so function first here. Okay, and by the way, if I wanted to, I could put this expression here in instead of the f. I could just copy and paste that in, but this is a little bit cleaner. Okay, so now I've got my three things I want to integrate with respect to. I'm setting the limits for each of the three things here. Okay. And when I evaluate this, this will give me, I already evaluated it, the area of the volume of a sphere. Okay, in the next lecture, I'll show you some more complex examples.